In this video, we shall see how reactivity series will help in prevention of corrosion. So there are two keywords which I mentioned. One is the reactivity series. It's a list of elements arranged in the decreasing order of their reactivity. So the most reactive metal will be placed at the top, and the least reactive metal, or we can say the least reactive metal, will be placed at the bottom of that list, called reactivity series. This reactivity series will help in judging which element is more reactive than which other element. And what is corrosion? Corrosion is a natural process in which metals react with substances around them. It could be like oxygen, it could be carbon dioxide, moisture, etc., and get transformed into some undesirable substances. So this is corrosion. Now we can see how reactivity series will help in prevention of corrosion, or the application of reactivity series in prevention of corrosion. For this, we shall take a question which was asked in IGCSE chemistry extended question paper of June 2021. Let's first see the question, and while answering that question, we can we can make ourselves aware of how the activity series could help in prevention of corrosion. So this is the question which I'm displaying now. Steel consists mainly of iron. Iron forms rust when it reacts with water and oxygen. Magnesium blocks can be attached to the bottom of steel boards. The magnesium does not completely cover the steel. You can look at the diagram there. In the diagram, it's very clear that there is a steel board, and then there are magnesium blocks. See, the steel board is not completely covered by the magnesium blocks. And water containing dissolved oxygen, it's also important here. So we'll see what is the importance of water containing dissolved oxygen. Now let's see the question. I explain how the magnesium blocks prevent iron from rusting. So iron will get rusted in the presence of oxygen and moisture, or oxygen and water. So you can see what there is oxygen which is dissolved in water, and obviously there is water. So this can make iron rust. Now, how can we prevent iron from rusting? We can use magnesium blocks, as he says. Let's see how the magnesium blocks prevents iron from rusting. Now, for this, we can take the help of reactivity series. In the reactivity series, as you know, the magnesium is placed magnesium is placed above iron. Magnesium is placed above iron. We also have aluminium, we also have zinc here. So these three metals are placed above iron in the reactivity series. This indicates that iron is less reactive than magnesium, aluminium, and zinc. Now, when you place magnesium blocks here, so magnesium, being more reactive than iron, will get oxidized more easily than iron. So magnesium will sacrifice itself by getting oxidized, and thereby preventing oxidation of iron, which we call as rusting. So now, what is the answer for this? Now let us first write this answer. Now, how magnesium actually helps in uh, prevention of rusting of iron, we shall see in detail after we answer this question. Now we are using this question to know how reactivity series helps in prevention of corrosion of metals. Here, rusting of iron. Rusting is a type of corrosion, as you know. So what should be the answer? If you see, the marks awarded for the right answer is 2 marks here. So let's see. So we have one thing is magnesium, Mg, symbol of magnesium, is more reactive than iron, that is Fe. Magnesium gets oxidized more easily than Fe, that is iron. So now the oxidation of magnesium will take place and the iron will be protected from oxidation or rusting. So we'll just see how we can use this magnesium in prevention of rusting of iron. For that, let me import another image. Yeah, you can see this diagram here. Here, though they say like this is the image, okay, of iron, and here we have zinc anodes here. So I'll just display the figure more clearly. So let me import the image again. So let's concentrate on this figure here. Here they have mentioned zinc anodes. So instead of zinc anodes, we can have magnesium. Why can we have magnesium as well? Already I explained to you that magnesium is more reactive than iron. Even zinc is more reactive than iron. Even we could have aluminum anode. So any metal which is more reactive than iron can be used to prevent iron from rusting. So now here zinc will act as anodes, and that's the positive electrode. Iron will act as cathode, it is negative electrode. There is a metallic path. Okay, so now just remember this point. Even though there is zinc, the mention of zinc anodes, it is even applicable for magnesium anodes. Here magnesium anodes will readily lose electrons than iron. Why? Because it is more reactive. Loss of electrons is can be defined as is nothing but oxidation. So oxidation can also be defined as loss of electrons. When do we say a metal gets oxidized? If it loses electrons. Here like instead of zinc, if you are using magnesium and then iron, magnesium loses electrons more easily than iron. So these electrons will flow through the metallic path and they will reach iron. So this will prevent oxidation of iron, or this will prevent the loss of electrons from iron, and therefore or thereby protect this iron from getting oxidized, or thereby getting oxidized, or iron prevent iron from rusting. In this way we can use magnesium anodes and protect iron from rusting. Here the figure is about the iron pipe getting protected by zinc. So the same thing is applicable for the steel that is used in making boats, and using magnesium blocks to prevent rusting of iron. So there must be some connection, some metallic connection, or some conducting path between the mm, anode and the cathode. Going back to the figure or the question, let me import that image again. So you can see here the steel boat will be acting as a cathode. Magnesium block will act as anode. Magnesium blocks loses electrons more easily. These electrons will flow through a conducting path that will be there between magnesium blocks and steel boat, and this prevents steel, the iron present in steel. Remember that steel is an alloy of iron, mainly it contains iron. So iron present in steel will not get rusted or oxidized. So as far as the answer is concerned, I just had written the answer. You just need to mention that magnesium is more reactive than iron. It will get more easily oxidized than iron, and therefore prevents iron from rusting. So this is the answer. Now coming to the next question. Explain why replacing of magnesium blocks with copper blocks will not prevent bottom of the boat from rusting. Here again, let's take the help of reactivity series. So what is the position of copper with respect to iron? In this question there is a mention of copper, and he's asking us to explain why we can't use why we cannot use copper to prevent iron from rusting. So if you look at the position of copper is below iron in the reactivity series. This indicates that copper is less reactive than iron, or iron is more reactive than copper. So out of the two metals, that is iron and copper, which will get oxidized more easily? Iron, being more reactive, will get oxidized easily. Oxidation of iron in the presence of moisture is what we call it as rusting. So iron will get rusted. Iron will not be protected from rusting. So let us explain. So how do we write the answer? This is just 1 mark question. You just need to write like this: copper Cu is less reactive than iron. Iron is more easily oxidized. Iron is more easily oxidized. In other words, it gets rusted. So in this way, copper cannot be used to prevent iron present in steel from getting rusted. Now it's better we see where all this process of using a more reactive metal to prevent rusting of iron. We shall see some applications for that. Before that, let me name this process. The name of this process can be sacrificial anode cathodic process, cathodic protection. Sacrificial anode cathodic protection. Here anode will sacrifice itself, it will undergo corrosion and thereby protect the cathode. So the cathode is the metal that needs to be protected. In this case it is iron, and anode can be magnesium, or it can be aluminum, or it can be zinc. So any metal which is more reactive than iron, when I say any metal, any suitable metal which is more reactive than iron can be used to protect iron from rusting by this process, sacrificial anode cathodic protection. So now we'll see where all this method is used. Here we have already one application. So that is we can prevent the rusting of iron present in steel, which is used to make boats. So I'll share with you another image which will tell you some other applications of this method, that is sacrificial anode cathodic protection. So this is the image. You can see here, sacrificial anode cathode protection is a method of mitigating corrosion, that is preventing or reducing corrosion to these important structures. So it is used in refineries, storage tanks, bridges, pipelines. The image which we saw before was about a pipeline being protected from zinc anodes. Even magnesium can be used, oil platforms and ships. So wherever steel is used, so if you need to protect steel or iron from getting rusted, we can use this method. I hope you have understood this. Thank you for watching. Please subscribe. Do not forget to subscribe, like and share. Thank you again.